Okay, today's video is about scientific measurements. Your essential questions that you're going to write down in your notes are: what is scientific notation? Why do we use scientific notation? And how do you write a number in scientific notation? Okay, so scientific notation is used for numbers that are really, really big or really small. So we're thinking about lots of zeros here. And so this is a way for scientists to be more efficient and not have to write out all those zeros. Okay, it consists of a coefficient, and then it's multiplied by a power of 10, and the coefficient has to be between 1 and 10. Okay, so first we'll just identify some coefficients. So we're looking for non-zero numbers. So for instance, in this first one, 10,000, the only non-zero is a 1. And so I move my decimal to right behind that number, and my coefficient is 1. Okay, we'll come back to that one in a minute. So next one, 1,000,000, again it's just 1. We put a decimal right behind that number, and then that's my coefficient. Okay, this next one, we have 3 non-zero numbers. So we have to think about where we want to put the decimal, but remember it needs to be between 1 and 10. So if I start with the 5 and put the decimal right there, 5.46, that is going to be between 1 and 10. If I put the decimal after the 4, that would be 54.6, that would not work. Okay, or after the 6 would be 546. None of those are less than 10. So we have to put the decimal after that first number. Okay, these next couple are going smaller. Same idea though. You're going to look for a non-zero number. So we have the 1, and in this case the decimal is going after the number. Okay, and so our coefficient here is 1. Okay, again on this next one we have 3 non-zero numbers. So we have to think about where we can put that decimal to make it between 1 and 10. Okay, so I'm going to put it right after the 7. I get 7.51. Again, if I put it after the 5, I get 75, and that's not less than 10, so that won't work. Okay, so that's how you find a coefficient. Now we're going to talk about the powers of 10. Okay, if you move the decimal to the right, your exponent on 10 is going to be negative, and if you move the decimal to the left, your exponent on 10 is going to be positive. So if we go back to this first one with 10,000, we don't have a decimal there originally, so what we do is just put it at the end. Okay, so that's where the decimal was. Then we're going to count how many places over the decimal had to move to get where it is now. 1, 2, 3, 4. 4 to the left, so we're going to put times 10 to the 4th. Okay, on the next one, again, we didn't have a decimal already in place, so if there's no decimal, you put it at the end. And again, we're going to count. 1, 2, 3, 4, 5, 6. Okay, so then I have times 10 to the 6th. Okay, on the next one, again, no decimal, put it at the end, and count. 1, 2, 3, 4, 5. So I have times 10 to the 5th. Okay, so each of those I'm moving to the left, so my exponents are positive. Now we're going to be moving to the right. So on this next problem, I already had a decimal in place, so I just have to count how many spots I slid the decimal over. So I have 1, 2, 3, 4, 5. Now it's to the right, so it's going to be negative, so I have times 10 to the negative 5th. Okay, next one, 1, 2, 3. So I have times 10 to the negative 3rd. Okay, usually you'll do one problem all at the same time, so we'll look at that here. On the bottom left here, you have that small number. So we have the 2 and the 9, and remember we want it between 1 and 10, so we're going to put the decimal in between. So we get 2.9. Then we would count 1, 2, 3, 4, 5, 6, 7. And we get 2.9 times 10 to the negative 7th. Remember, we're going right, so that's why that's a negative. Okay, 12,450. I start with that 1. Again, I need the coefficient to be between 1 and 10. So if I put my decimal there, 1.245, that works. Okay, and then I'm going to count. My decimal was at the end because I didn't have one showing. 1, 2, 3, 4 to the left. So I end up with 1.245 times 10 to the 4th. And we do not take out numbers that are non-zeros, okay? And if a zero is sandwiched, you don't take it out either. All right, sometimes these don't get written correctly, so if it does not fall between 1 and 10, it has to be rewritten. So if you look at the problems here, 100 is not in between 1 and 10, and 0.0001 is not between 1 and 10, and so on. So these are not written correctly. So when you're fixing them, if you move the decimal to the right, you're going to subtract it from the exponent. And if you move the decimal to the left, you're going to add it to the exponent. Okay, so 100 really should just be 1. Okay, so remember we put that decimal in at the end, 1, 2. That's where I want to put my new decimal. Okay, so I'm going 2 to the left, so I'm going to add plus 2. So I get 1 now, so that's in between 1 and 10 times 10 to the 5th. Okay, next one. I'm going to put the decimal after the number. I'm going to go to the right, 1, 2, 3, 4. 4 to the right is subtracting 4 from what we had, 10 to the 12th. So here I get 1 times 10 to the 8th. Okay, next one, we need to put in our decimal that's not there at the end of the number. We're going to go 1, 2, 3. Because if we put the decimal there, it'll be between 1 and 10. We went 3 to the left, so we're going to add, so negative 7 plus 3. So I get 4.49 times 10 to the negative 4th. Okay, last one. I am going to put my decimal after my 6. I count 1, 2, 3 to the right, so I'm subtracting. So I have 3 minus 3. So I get times 10 to the 0, and anything to the 0 is 1. So it's basically 6.5 times 1, which is just 6.5. Okay, so for this next part, calculations, we're going to use our scientific or our graphing calculators, and we're going to work on using the EE or EXP button. So we'll do this in class together, but basically on this first problem, what you would enter exactly is 2.4. Then you would push your EE button and just push 6. Okay, that just replaces the times 10. And then you put times 3.1 EE3. Okay, so we'll practice that in class together so I can show you on the calculator.